Okay, Bismillah Rahman Rahim. So our today's topic will be uh, splines. In our last lecture, we had started a discussion on polynomial-based modeling, and in today's discussion, we will talk about splines. Okay, so splines are an example of polynomial based modeling, and I will start by an example. Let's say we have these points. This is independent variable and this is a dependent variable, and let we plot this. We select scatter plot and we get these points. Okay, so let I create a polynomial based model for these points. Add trend line, display equation, display r squared value. Okay, and now uh, if we select a linear equation, so the r square value is 0.03, but we are interested in polynomials. So let's say we select polynomial, and if we select a polynomial of order 2, so we get an improved a model with r square value as 0.0651. Now if we increase the order of the polynomial, and we change it to 3, so our model is improved, and now the r square value is 0.232. Now if we increase the order, so the value is further improved and it becomes 0.6247. If we further increase the order, so we get an improved value. And if we go to higher order, let's say the Excel provide the facility with maximum order 6, and with this order we get the value of r square as 0.7793. Now with this order 6, we get the model with accuracy of 0.7793. Now we can do this with an alternate method. Okay, and let's say we consider piecewise polynomial, and piecewise means that we divide the points. Okay, now I consider this set of points 5 7 12 5 4 3 2. Okay, now I consider these points. Okay, this is one set of points, and these 3 5 7 9 15 8 6 5, this become another set. Okay, and now I create a model for these points, a trend line, and I show the equation and show the r value. Okay, and now I get I select the polynomial, and if I take a polynomial of order 2, so I get this value 0.537. If I increase it to order 3, so I get further improvement for order 4. This is zero point 0.7, and for order 5, I already get an improved model as compared to the previous one for this set of points. And now for other set of points, I create another model, a trend line, and I display the equation and the r square value, and I select the polynomial for for order 2. I already get an improved model 0.66, but if I increase the order, so 0.67 and 0.79. Okay, now if we compare these two values, for first set of values, the polynomial is of order 5 and the values are 0.87, and here the polynomial is of order 4 and the r square is 0.79. Okay, so with lower order I get an improved model when I divide the whole function into two functions. Okay, and this is also called piecewise polynomial, mean that I divide the polynomial into pieces. Okay, now in this case it was one piece, and for order 6 my accuracy was 0.77. Now, and when I divided the points into two pieces, so I get an improved accuracy with lower number of polynomial order. And now if I further divide these points into sub pieces, let's say I take one piece for these points, 5, 7, 12. Okay, I get one piece is this one, the second is 5, 4, 3, 2, the second piece is this one. Okay, and the other piece is 3, 5, 7, 9, 15. Okay, this is another piece, and the fourth piece is this one. Okay, now I have these four pieces. Okay, and if I create a model for these 3 points, so uh, display R and display equation. And now with linear equation my model is already is with very high accuracy of 0.97. And if I this is for linear equation, and if I take polynomial, so for polynomial of order 2 I already get the best or the most accurate model for these points. Now for these set of points, let I create a model, trend line. And if I first I show the equation. Okay, if I consider the linear model, so I get an accuracy of 0.92. But if I get a polynomial, so with order 2 it is 0.97, and with order 3 0.99. Okay, so for this is 1, for this piece, this is 0.99, and now for this piece, let I create a model. Okay, okay, sorry. There is one. Oh, sorry. Okay, now I display the values, and for linear equation I get the accurate model with r square 1. It is a perfect model, so I don't need a polynomial for this because I already get a perfect model. And now in this case, a trend line display r squared. Okay, now uh, for linear model I get an accuracy of 0.96, but if I get polynomial of order 2, so I get a perfect model. So now when I divided the function into sub functions, so with these sub functions I get a model with accuracy better than the previous one. Here the accuracy is 1, and here it is 0.99, it is 1, it is 1. So what does this mean? This means that if I divide a function into sub-functions or a sample into sub-sample spaces, then I get better accuracy. Okay, so now I go back to the presentation. 1 minute. Okay, so I give you an example how the piecewise polynomial practically works. Okay, okay. Now we come to the definitions of polynomial. So in computer graphics, a spline is a curve that connects two or more specific points, or that is defined by two or more points. So these piecewise functions are called splines. In mathematics, spline is a piecewise polynomial. Spline is a mathematical function used for interpolation or for smoothing. These are examples in image processing or sampling. Okay. Now, in my practical examples, I showed you these samples. Let we have these points, and if we consider a function of these samples as a single function, so with polynomial of order 6, I get a model with accuracy of 0.7793. Now, if I divide this function into two subfunctions, or this means that if I take two splines mean that two pieces of a single function. So the accuracy of the first piece is this one, and the accuracy of the second piece is this one. This is 0.87, this is 0.79, this is of order 4, and this is of order 5. So when I divide these the single function into two sub-functions or two splines, so I get a comparatively simple function with better accuracy. Okay, now this is the same function if it is divided into four pieces. Okay, one piece consists of these points. Okay, so these can be modeled as linear function with accuracy of 1. The other points are these one, and again we can get develop a linear model for this minus x plus 6, and it is modeled with accuracy of 1. This means that this is the perfect model. And for the other set of points, like these are the other set of points. Okay, and this is modeled with accuracy of 0.99, and these set of points. Okay, these are other sets, and again these are modeled with accuracy of r square. Now what does this mean? This means that we had a complex functions, a complex set of samples, and we developed a complex function for that, but the accuracy of that function was not uh, as better. So we divided that set of samples into four subsamples, and we developed models for these subsamples, and with this we got an improved accuracy, while the model is comparatively simple. Okay, so these pieces are called splines. Okay, so spline is actually dividing a complex function into simple small functions. Okay, spline may be linear, quadratic, or cubic. This is linear function. This is quadratic function of order 2, and this is cubic function of order 3. Okay. Linear splines connects the linear dots with a linear function. Here 6-line function are used as shown. Now we have the samples, but it is divided into 6 linear functions or points. Okay, So we can either model it as a complex polynomial, or we can model it as simple linear functions, but the number of functions will be more. So here a complex polynomial is divided into 6 linear functions. Okay, quadratic function. So it is a second order polynomial. In the quadratic function, we connect the linear dots with linear functions. Okay, so this is a complex function. Now it is divided into quadratic function. One function is this set of value, another function is this set of values, and another function is this set of values. So it is divided into 3 quadratic functions. Okay, and cubic functions. So this function is divided into 2 cubic function. One set is this one, and another set is this one. Okay, now splines has many applications, and now I think at this stage it will be not very easy for you to understand, but uh, I will go to the applications. Okay, now in modeling or in image processing and computer graphics, uh, these are the splines are used to represent complex shapes. Okay, now for example, face is represented mathematically by by these piecewise functions. Okay, okay, these are other examples in computer graphics and image processing where complex shapes are represented using mathematical equations. Okay, thank you.